Hello, and welcome. This is the Chapter 9 video review, and what I'm using here is the solution guide for the practice test. So, the thing is, you already have an answer key for this. In fact, you looked at the whole thing, you scored your own stuff based on it, but you still might have questions. You still might say, well, I still don't really see, I see the step, I just don't know how you got from one step to the next. For the most part, I did lay it out, so essentially anything that I write on here will not be much different from what you saw on that key. But, I mean, at the same time, you might see somebody, do a backflip or, play Freebird on guitar or something. Just because you see it doesn't mean you know how to do it. So, if this is to your benefit, then that's awesome. But I will be rushing through it a little bit. If you can see the time right here, I have class in 1 hour, and I really do have to be finished well before that to make sure I'm all prepared. So let's get started. Okay, this was number 1 on the practice test. Z varies jointly with X and Y. So automatically you're saying, okay, Z is equal to your constant of variation being multiplied by X and Y. Z also varies inversely with the square of W. So varying inversely with W would just be like that, but the square of W is squaring W. Now be careful between square and square root, or cube and cube root, or something like that. Obviously, those are two different things. Okay, so that's your first setup. You're good to go. And by the way, here's joint variation. Here's that idea. The Z is there. There's inverse variation being divided by your constant, this and that. And the rest is kind of substitution in a way. We're going to find the constant of variation. We're going to solve for K. So let's go ahead and you can even set this up right now by substituting, or you can set this up by solving for K. For instance, if I multiplied both sides by W squared, and I divided both sides by XY, then I'd have this. And now I can just substitute from here if I want. So substituting, if W equals 8, it looks like Z equals 3, just writing this on top first. K and Y, or X and Y are 4. I'm going to go ahead and get K equal to 3 times, well, maybe I shouldn't have done it this way, but 3 times 8 squared is 64, times 3 is 192, all over 16, 160, 12. So K is 12, so your equation, using your constant of variation here, is that Z equals 12xy all over W squared. And now you can use that. So now you're given any other 3 variables, you can solve for the last one now that you know your constant of variation. These aren't very easy to graph when you have 4 dimensions of values, of axes here. So we're not going to graph it to make sense of it, but at least you can still kind of make sense of what we're trying to do. So let's go ahead and solve for W. Find W when X equals 1, Y equals 6, and Z equals 2. And like I said, on the sheet, you can substitute straight up like I did on the sheet. Or you can manipulate this. Let's go ahead and do W squared right now. Take the square root of that even. W is plus or minus the square root of 12xy over Z. Now you can substitute if you want right from here. W equals plus or minus. I'm not recommending you do it this way. I'm just giving you options because maybe on the worksheet we did it a different way. So X is 1, Y is 6, and Z is 2. 12 times 6 is 72. All over 2. It's plus or minus square root of 36. And that is plus or minus 6. So there's your value for W there. Okay. And that's direct inverse joint variation. There's K is the constant, etc. Okay, let's go and do some graphs here. Number 2, sketch the graph of the following functions, including any asymptotes and holes. So first you want to get it kind of in good old standard form for reciprocal functions, and here it is. If you have an A value on top, which is a very good reference value. Ooh, this didn't really translate well. I'm sorry. This should say, let's take care of that right now. I'm sorry. Should look like that for you. There we go. A is a reference value, meaning we use that number and we can find factors of this value here and we can divide them, etc. I'll go ahead and do that in a second. And then H is displacement of your vertical asymptote and K is the displacement of your horizontal asymptote. So what I'm going to do in this first one is there is no h value, so there's no vertical displacement of your horizontal asymptote. That means it's right across here at x equals 0. And then you have another one, k is your displacement of your horizontal asymptote. K is -2. So my horizontal asymptote is going to go ahead and go right across here. Good to go. Everything that I'm going to do is now going to be in reference to this cross section right here, where I go from. So what I'm going to do is pick values that are to the left and to the right of here. And I'm going to choose factors of my a value. So factors of 8 are 1, 2, 4, and 8. And obviously -1, -2, -4, -8. What you're going to see here is when I go over 1 to the right, I'm going to go 1 away from my cross section, and that is also when x equals 1. So I'm going to get 8 divided by 1 there. 8 divided by 1 is 8, so I'm going to go 8 up from here. Right there, and I'm actually going to use a different color. Let's go ahead and use red again. Now why did I... Actually, let's use a different color. Now why did I choose to go 8 up and I'm at x equals 6? Well, 8 minus 6 is 2. Or 8 minus 2 is 6. So everything we're going to do, again, is in reference to your horizontal asymptote right there. If I go 8 away, 1, 2, 3, 4, 5, 6, 7, 8, I will be 8 divided by 8, which is 1 up from there. The other two factors are 2 and 4. If I go 2 away, I can divide by 2, so I'm going to go 4 up. If I go 4 away, I can divide by 4, so I'm going to be 2 up. These are enough points for me to look at. When it comes to graphing this, unfortunately, I can't graph very well on this thing. But that'll be good, and I go with half arrows to represent it's going to be continuous, but it's not going to cross through its asymptote right there. And same on the other side. If I go in the negative section, I go -1. I'm going to divide 8 by -1. I'm going to be 8 down. Same with these guys right here. And again, I have to be slightly time conscious, so if it seems like I'm going too quickly, just let me know. And obviously, I'm graphing what's already on your key, so that's why I do want to explain as I'm going instead of whatever else. So in explanation for here, I'm doing 8 divided by these values, how much I'm going over from my cross section here. When I go 1 over to the left, I'm dividing by -1, so I get -8. Divided by -2 is -4, etc. I'm going to do it again here, only now we have to do a couple more things on this one to finish solving it. Number 2, well, there's no number 2, but y equals this, and you're like, oh, I don't know how to graph that. Well, neither do I. But if you factor this a little bit, if I factor out a -2 to get a good old x leading variable in there, I'm going to get x minus 5. If I factor out the bottom, I'm going to get x minus 5 times x plus 1. Now you see that these x minus 5s cancel, and all that's left is y equals -2 over x plus 1. Now it's probably good to note right now, immediately, that you canceled some values where you might be getting, if you substitute 5 into this equation, you would be getting 0 over 0, which is an indeterminate. Indeterminants are where your holes are. So you have a hole at x equals 5. We need to find the y value that associates with that. But as you graph it, you can probably also just replace where that hole is. But if you substituted for 5, you get 0 over 0. But what point does this graph jump is the question. But let's go ahead and graph based on this form right here. We know that our h value is -1. Remember, it's x minus h. So our h value is -1. We're going to be 1 to the left here. And then there's no vertical displacement, so we're going to be right across from there. In terms of graphing this now, okay, we need to pick everything in relation to, okay, so what are the factors of -2? There's 1 and -2, and there's -1 and 2. There's not much to go off of. So we're going to pick, we're going to pick some points. We're going to see what we can do. Like if I go 1 to the right here, then I'm going to be doing -2 divided by -1. Remember, 1 to the right, everything's in relation to the cross section. So when I go 1 to the right, I'm not at x equals 1. I'm at x equals 0. But I'm at the value for x, so that I will be dividing by 1. Notice when I substitute 0 for x, I'm getting -2 divided by 1. So if I just do everything in relation to this cross section, I just have to say, if I go 1 to the right, I'll be doing -2 divided by 1. If my asymptote was way over here, and I go 10 to the right, this will be -2 divided by 10, etc. Anyway, negative 2 divided by 1 is negative 2. So here's a point right here. I go 2 over. Negative 2 divided by 2 is negative 1. And I can still pick some more points. I don't want just these. I could keep going over. Negative 2 divided by, this isn't that great of a number, but 3 is negative 2/3. Negative 2 divided by 4 is negative 1/2. Negative 2 divided by 5 is negative 2/5. And negative 2 divided by 6 is negative 1/3 right there. But this is also x equals 5. This is where your whole exists. And what did we say it was? Negative 1. Did I say negative 1/6? I meant to say negative 1/3 if I did. So my whole is at 5, negative 1/3. Okay, not the easiest one to find, but there it is. And if you go this way, that's what's going to happen. It's going to jump that value and continue going. It should be approaching your asymptote, but it'll keep going that way. This way too, negative 2 divided by, well, negative 2 divided by 1/2. Not 1/2. Negative 2 divided by 1, negative 2 divided by, yeah, let's do negative 2 divided by 1/2. That's negative 4. Negative 2 divided by 1/3 is negative 6, etc. So this would keep going that way as well. And I do the same thing on the other side. I'm just going to rush it. This one will not have holes on this side. This will be going straight through. This doesn't have any feature where you're going to get 0 divided by 0. And your asymptotes are x equals 1, negative 1, y equals 0. Okay, here we go. There are some rules here on top. You can go ahead and read them. This is in terms of simplifying expressions. If it says simplify the rational expressions, I want you to make sure that all of these things are covered, because if they're not, you probably haven't completely simplified it. The only other thing that I'll probably hit home with, not too deeply here, though, is just make sure we get our factors right. So I'm not going to say how to do it. I'm not going to keep drawing diamonds. I'll do them mentally, and obviously they're on your paper. But I'll say the two numbers that add to negative 11 and multiply positive 24 are x minus 3 and x minus 8. Now when I'm multiplying here, or negative 3 and 8. Now when I multiply here with two fractions, I can multiply straight across the numerator, multiply straight across the denominator. So in my next step, I'm going to immediately assume that I can just multiply this by the next two guys. The two numbers that multiply to positive 15 add to negative 15 are negative 10 and negative 5. So I'm just going to go straight across right there, and I've already taken care of one of my things, like terms are combined including rational numbers. I probably should have also written something like, the reason why I said that is to say that I want to make sure that these are combined as to one fraction, but I probably should have also said leave answers one fraction, not two. Anyway, I digress. So at this point, let's look at the bottom. Two numbers that multiply to positive 80 and add to negative 18 are negative 10 and negative 8. And two numbers that multiply to positive 20 and add to negative 9 are negative 5 and negative 4. From there, because everything is common multiple with one another, you can now divide things that are identical on top and bottom. So I have x minus 10, x minus 8, and x minus 5. And all that's left is, this isn't, you're not solving for x, but all that's left is x minus 3 over x minus 4. That's your final answer. Restrictions are you cannot divide by 0. So you have to look at, even from the original equation, you have to say, even though these cancel out, remember wholes, when are you going to divide by 0? What do we have to avoid? What can't x equal? Well, it can't equal 10, 8, 5, or 4. Okay, B. People teach it differently. What I'm going to do is group the numerator as its own guy and the denominator as its own guy. And if you see on the key, I draw arrows, I believe, because I just did it recently. I draw arrows out to here to just reference and say, here's what I'm doing next. I actually do it over here. Here's what I'm doing next. The next step that I'm going to do is find a common denominator with the numerator. Find a common denominator with a denominator. And then that way, when I divide, and I'm going to divide linearly, by the way, meaning straight across instead of up and down, I can then multiply by its reciprocal. So then I can get something that looks a lot more like this. This is a lot easier to take care of when I'm doing this kind of problem. So 3 plus 5 over x plus 2. If I multiply 3 here by x plus 2 over x plus 2, then I'll have a common denominator. And now I'm going to have 3x plus 6. It's 3x plus 6 plus 5, so 3x plus 11 all over x plus 2. So the way that I've rewritten it is significantly easier to read as just one nice thingy right there. And I'm going to divide this then by what's on bottom. If I go and draw another arrow, let's go and do a different color. If I do 3 minus 10 over x plus 7, and I multiply top and bottom by x plus 7 over x plus 7 for 3, then I'll have a common denominator, and this will then become 3x plus 21 minus 10, so 3x plus 11 all over x plus 7. So this will now be divided by, if I move this a little bit, this will now be divided by 3x plus 11 over x plus 7. Okay. Now that I've divided, dividing is also multiplying by the dividends. Oh, I always forget that. The other guy is opposite reciprocal. The guy on the right, the one you're dividing by, that has to flip. Be careful not to flip the first one. Be careful not to flip both. Okay, it's just the last one. So this becomes 3x plus 11. And now that I'm multiplying, I can actually, well, I'll do it on the next step, but when I'm multiplying, I can do exactly as I did here and group it all as one fraction. And you'll kind of see the benefit. Like, you take a look at this and you say, nothing here can cancel out. These are different fractions. Well, really, when you're multiplying, it's all just one fraction. So this next step here, I can just go ahead and say, this is 3x plus 11 on top, x plus 7 on bottom. That's an x, by the way. And another cool thing is multiplication is commutative, which means I can reverse the order or switch the order in which I multiply things as long as I maintain their values. 3x plus 11 times x plus 2, I can rewrite it like this. The only benefit is I can clearly see that, oh, 3x plus 11 is clearly a common multiple on top and bottom. These can divide. And all that's left here is x plus 7 over x plus 2, which is awesome. Now, there are restrictions here. Once again, you want to say, well, what can't x be? When I'm ever looking at a denominator, if I'm looking, right, here, in this case, when I'm dividing by x plus 7 up here, that's a big one. X plus 7 here, x plus 2 here. When I'm doing 3x plus 11 right down here, I want to say none of these can equal 0. So two obvious ones are x can't equal negative 7 or negative 2. And the last one here, you want to say 3x plus 11 cannot equal 0. 3x cannot equal negative 11, so x can't equal negative 11 thirds. So that would be your third restriction right there. So all three must be validated in that way. Never dividing by 0 in any sense. We have two more. Same rules apply on top, and I'm just going to maintain those right here. This one's more of a Chapter 7 feature. We haven't seen something like this in a while, so I want to make sure that you do understand these two concepts. First of all, a over b raised to the x power is a to the x over b to the x, meaning I can distribute the exponent into common multiples. Not common multiples. I can distribute an exponent into a fraction. And also, if you have a multiple within here, I can also distribute it that way. So I'm going to make sure to distribute this 2 into the 4, the x, the y, and the z cubed. So the final thing I want to make sure that you know is a to the x to the y power equals a to the x times y. So these three properties are very important for this guy over here. I'll go ahead and do those first. We're going to get 4 squared. I'm just going to write this as one step. 4 squared is 16. X squared is x squared. Y squared is y squared. And on bottom, we're going to have z cubed quantity squared. So like this, z to the third power, all raised to the second power. That's going to be z to the 3 times 2 power. So that's z to the 6th power. Okay. Now we are going to divide this fraction, which means multiply by its reciprocal. So we're now going to get 2x cubed y all over z to the 5th times z to the 6th all over 16x squared y squared. Now that I have this, it's probably also written on your sheet. I'm not looking at it, but it would be nice to just write things on top and bottom as they most closely associate with another. So first of all, numbers first, and then go alphabetically. Now this can all be as one fraction. Now, not just two fractions, because it's multiplied. All is one fraction. I'm going to write the 16 first, and then x squared, y squared, z to the 5th. A lot of different ways you can do this. Some people go straight to subtraction and whatever else. So I'll go ahead and do it that way. First of all, 2 over 16 is 1 over 8. X cubed over x squared is x to the first power, 3 minus 2. Y over y squared is y to the first minus y squared. That's y to the negative, or not minus, but 1 minus 2. It's y to the negative first power. Z to the 6 minus 5 is z to the first. So your final answer should look like x and z on top over 8 on bottom. I wrote a y. X and z on top over 8 on bottom. And remember, y to the negative first, here's your last property, that's 1 over y. So y will also be on the bottom as well. So there's a lot of different stuff you want to write there. And like I said, I probably didn't write all of that on the sheet. So these are just different ways you can go about it. Restrictions, you just want to not divide by 0 ever. So you want to look at any scenario in which case you substitute x, something for x to get 0, something for y to get 0, something for z to get 0. Now y is the one that exists on the bottom in the end, but notice how x's and z's canceled earlier on. You want to make note of that as well. So you want to say, well, if x squared can't equal 0, then x surely can't equal 0. If y squared can't equal 0, then y surely can't equal 0. If z to the 5th can't equal 0, then z surely cannot equal 0 also. Remember, if any of these become 0 at any one time, you multiply the whole bottom by that 0 number, you're dividing by 0. You don't want that. There are your restrictions. Okay, D. This is a subtraction problem. And in subtraction and addition, you have to get a common denominator first. Okay, so let's work toward that. To do that, one of the first steps that I'd always recommend, it's not written up here, I don't think, but you want to write in factored form anyway. Get in factored form wherever you can, because there are chances you can clean up some numbers before you even start finding a common denominator. And better yet, you start doing this right here, you're going to see what common multiples are already shared. You don't want to multiply the entire bottom. Excuse me. You don't want to multiply the entire bottom by the other guy if there's a common multiple. Like if I do 1/4 times 1/6, I don't just want to multiply by 4 over 4 and 6 over 6 because they both have a common multiple of 2. Because instead, I can multiply by what's missing in the other one, right? This is 1 over 2 times 2, and this is, oh, sorry, let's say this is minus. And this is 1 over 2 times 3. Well, they both share a common multiple of 2, so multiply by what's missing in the other guy. This one's missing another multiple of 2. This one's missing another multiple of 3. So you can multiply by less than you need to. Maybe not as big for this value right there, but for this, oh yeah, it's absolutely important. These both share an x minus 10. Multiply by what's missing over here, which is x plus 5. Multiply by what multiple is missing here, which is x minus 8. Instead of multiplying by the whole polynomial, distributing, getting an x cubed thing, having to deal with that and factor it, that'd be really difficult. So you have the same thing on bottom already. So I'm going to go ahead and write this is all over x minus 8 times x minus 10 times x plus 5. Once you have established the fact that you found a common denominator, you don't need to write them as two separate fractions anymore. Now they can be merged as one fraction. Now the idea is to distribute, so you can then combine like terms and see if something's possibly factorable on top. 3x distributing with x minus 8, I'm going to get 3x squared minus 24x minus, this is going to be important right here. I'm going to write this in a different color, black, minus, I'll write this in parentheses. Just pretend like this minus is away from here right now. Just look at 4. 4 times x, 4 times 5. Okay, there's a plus within the parentheses, and I'm going to be subtracting that. So in the end, this will end up distributing into the negative, or into the 4x and the 20. So I'm going to get 3x squared minus 24x minus 4x, that's minus 28x, minus positive 20, so minus 20, all over x minus 8 times x minus 10 times x plus 5. Two things before I move on. First of all, I'm not done with my answer. I want to first see if this can be factorable for good reason. If something can cancel on top and bottom, that means you can further simplify it. Actually, three things. Secondly, we still need to do restrictions. But thirdly, I've seen this a little bit. When we've been talking about using equations and finding a common denominator or least common multiple so the bottom can then go away, that's in equations. In an expression, you can't just cancel this out and say, oh, it's gone now that I found a common denominator. No, this is a part of your number. Remember, this is a number. We can't just change 3 over 2 and go like, oh, I want to cancel out the 2 when that equals 3. You can't change the value. That's why we do common denominators and everything else. We need to make sure that the value stays as it is. So let's see if this is factorable. And like I said, time right now for me is a factor. So I'm going to keep going here. I do these mentally, but I'm going to go ahead and work with you here. I'm going to do 3 times negative 20. It's negative 60. Find factors of negative 60 to add to negative 28. Because in the end, one of these numbers multiply by negative 3. Someone's going to have to help me out here. I can't remember what my numbers were. Negative 30 and positive 2, right? Negative 30, positive 2. If we write this out, if we spell it out, we're going to get 3x squared minus 30x. I'm rewriting plus 2x minus 20. I'm rewriting negative 28 as negative 30x plus 2x. All over this. I realize your sheet obviously didn't have as much room as I do right now. That's why you can always use scratch paper or write smaller. Factor by grouping. This is revisiting chapter 5 for sure. Common factors here. I have a factor of 3x here. I'm going to be left with x minus 10. I have a common factor of 2 here. I'm going to be left with x minus 10. Your goal is to get a common factor within your common factor. Pull out a common factor so you get common factors within these two terms. X minus 8, x minus 10, x plus 5. So this becomes 3x. If you pull out the x minus 10 from both terms, you'll get 3x on one term and plus 2 in the other term. Like that. And here we go. Obviously this was a bigger problem. Now, you've written it in factored form. You get to say, hey, does anything cancel on top and bottom? Oh yeah, x minus 10, because they're common multiples on top and bottom. So you get to do that, and your final answer then, after all that work, is 3x plus 2 all over x minus 8 times x plus 5. No need to redistribute back in. You're good to go. Restrictions, however, x can't equal 8, 10, and 5, or negative 5. Remember that 10 as well. Don't forget, even the ones that cancel are still needed. So you can go and read up on those rules in terms of considering what you want to meet when simplifying expressions. Okay, solving equations. There are two different ways that you can go about this, really. And technically 3. The second one has 2 different things. So I'm going to do one with one way, one with the other way. This one, actually, there are quite a few ways to do this, actually. The way I did it on paper probably wasn't the easiest. Notice, this is a common denominator already. What I could have done was added 5 over 2x on both sides, and this technically takes care of what number 1 would accomplish. If you find a common denominator on one side and find a common denominator on the other side, it doesn't have to be the same thing, but if you find that common denominator, then you can make it into just one fraction on both sides, which can allow you to do cross multiplication. 3 plus 5 is 8. I can do that because I have a common denominator. That's 8 over 2x. So I'm going to go and do it this way because I feel like I didn't do it on the paper. This is something that you can probably recognize, and I'd love for you to do it if you can. Now you get to cross multiply. 2x times 3x, 8 times x plus 1. I'm going to get 6x squared equals 8 times the quantity x plus 1 is 8x plus 8. So you got to solve for x now. This is an equation, so I'm going to subtract everything over. I could use, completing the square. I could use quadratic formula. But I'm going to go ahead and divide both sides by 2. 0 divided by 2 is 0. Make my numbers a little bit smaller. So I'll just write that because maybe you're just listening and or watching and not listening. Divided by 2, divided by 2. Okay. Let's do this one quickly. Negative 12, negative 4, it's negative 6 and 2, 3x squared. Mind you, if you there are ways to do this in your head. If I've used a teacher and if you want to learn it, you can stick with me for a while and I'll practice it with you. But I want you to see what I probably didn't write on your paper. Hang on a second, that should be minus 2. What I didn't write on your paper, so you can say, well, wait a second, how do you do it? And what's happening here, once again, this is factoring by grouping. I'm going to go ahead and split this off, negative 4x, into these two terms. And then I'm going to say there should exist a common factor here and a common factor here. And when I pull those common factors out, I will have a common factor of those factors within there to then factor out. So for instance, when I pull out the 3x, I have x minus 2. When I pull out the 2, I have x minus 2. And that x minus 2 I can pull out of the 3x and the 2. And I'll get that. So 3x plus 2 equals 0. Remember, it's not can't equal 0. It's equals 0. 3x equals negative 2. X equals negative 2/3. Okay? And then x equals 2. So there you go. I've seen a couple times, I've seen people, solve these. They get those, and then they list restrictions. They go, oh, by the way, x can't equal 0, and x can't equal negative 1. Like, okay. No, it can't. You're right. It can't equal 0, can't equal negative 1, but it's really because, not just because you can't divide by 0, but because x does equal these. So you don't have to write this. You already say what x can equal. Basically, x can't be anything but negative 2/3 or 2. Now, what be a good reason to do this maybe is to check and see what your restrictions were supposed to be, because if your restrictions are one of these two numbers, then these would be extraneous solutions. Another way you can do that is substitute negative 2/3 or check. If I substitute negative 2/3 into the original equation, do I get 0 on the bottom? No. If I substitute, was it 2? If I substitute 2 into the original equation, do I get 0 on the bottom? No. So these are not extraneous solutions. Right here, these are correct answers. There they are. Other solving equation right here. I'm going to do this the second way, find the least common multiple, to either do one or the other, create a common denominator, or to straight up clear fractions. Meaning, once you know what your least common multiple is, then you can either multiply both sides by that exact value, or create a common denominator as you go. So, I don't know. I'll do both ways if I have time. So let's see here. I have 10 over x times x minus 2, if I factor that, plus 4 over x equals 5 over x minus 2. So what you're seeing here, in essence, is this term has both multiples of what these other guys have. And 4 over x is missing a multiple of x minus 2 over x minus 2. This one guy right here is missing a multiple of x over x. So the way that I see it is really just going about it this way. You do end up multiplying the top just by what's missing. And now what you have essentially on the bottom, I mean, I'll go ahead and write it one more time, but what you have now on the bottom is, remember, we haven't yet changed our values, so I have 10 over x times x minus 2, plus 4x minus 8 over that. Remember, I could have written this just as one fraction over there, because it's a common denominator. Okay, the idea here is what, did I write it here? I did not. If a over d plus b over d equals c over d, then a plus b equals c. If all of these are being divided by the same thing, then what other numbers could these be other than the numbers, that they are? Like, if I multiply both sides by d here, then the d's cancel out. They're all gone. So that's the idea. If I can just multiply both sides by whatever the denominator is, then the fraction's gone, and I'm taken care of. So you can either write that. You could say, I want to multiply both sides by x times x minus 2, which would cancel them out. Or you can just say, okay, I'm at that step. I can just go ahead and ignore them. They are not needed anymore. They are not necessary. The difference between this and the expression example is this is an equation. I can multiply. I can literally manipulate these numbers and change them. All I need is balance. In expression, things such as this individual term, I can't change the value. I can do x minus 2 over x minus 2 because that number is 1, and multiplying by 1 does not change my value. Anyway, I get 4x plus 2 is 5x. Subtract 4x, I get x equals 2. That's my only solution, and now what I want to do is make sure that I do not end up dividing by 0 if I substitute 2 into any part of the equation. 4 minus 4. Uh-oh, I divided by 0. 2 minus 2. Uh-oh, I divided by 0. X equals 2 is no good. This guy stinks. It's extraneous. So what does that mean? There are no other values for x. What does that mean? What can you do? Nothing. There is no value for x for which you can solve this equation. It is impossible. This is no solution. And if you feel extremely compelled to also say, because here it would be dividing by 0, oh, x can't equal 0, well then, brownie points for you, but no actual physical more points for you. Obviously, there's no solution. X can't equal 0. X can't equal anything, especially 2, even though you solved for it. Okay, 2 more problems, and then I got a jet. This is one type of word problem where we're going to look at 2 different rates, two different individual rates, and they can combine as one. And this is an example of one. If you, the example I gave in my class was using Boy Meets World, and this is exactly where these character names are coming from, Corey and Sean, where they're hearing a word problem about 2 people, Al and Fred, washing cars. Al washes his car, and this time Fred washes his car, and this time how long does it take to together? Like if Al takes 6 minutes, Fred takes 8 minutes. We don't add the times to say together it would take them 14 minutes. You could, I guess, physically say if Al spent time washing a car and he spent 6 minutes to do it, and then he took a break and Fred went in and washed another car, it took him 8 minutes, then together it took them 14 minutes to wash the 2 cars. But if you're trying to wash the same car, your time is going to be less than 6 minutes because Fred, no matter how slow Fred is, Fred will still be doing some part of the car. Al will be doing at least most of the car, but it'll take less than 6 minutes. So anyway, you can add up the rates because Al goes at a certain rate, and when Fred joins in with his rate, you are combining rates. I digressed, I'm sorry. Distance equals rate over time. Now, distance doesn't have to be actual distance traveled. It can just be how much work is being done. If you wash a car, right? If you create invitations, if you solve word problems, stuff like that. Also, rate is a factor. If you want to write it this way, is distance over time. Once you rewrite it that way, Corey and his best friend Sean were assigned as partners on their multiple choice quiz. They split the work to save time, answering all questions on one Scantron. So that means that they can kind of do their own work. He'll go like, okay, I'll do numbers 1 and 2, and you do these ones, whatever. We'll just fill them out. Together, they finished the quiz in 18 minutes. Awesome. So here we have Corey, Sean, and together. We want to kind of use these things and say, what things are we looking at? Time and rate. This is all in the same kind of test, that certain length that they took. The time together it took was 18 minutes. Remember, that's not going to be a sum of this number and this number. It's not going to be like 10 plus 8. It'll be 2 values that are unrelated in that way, but the rates will be so related in that you can add these guys' rates together, and this will be your together rate. Following week, by the way, this is the time to do, your distance is 1, essentially. This is the time to do 1 test. Okay, so 1 test for their rate together equals 18 times their rate. So their rate is 1 over 18. Another way of saying that is after 1 minute, they will have completed 1/18th of the test. You have to use this is 1 test per 18 minutes. The following week, Corey and Sean each took an individual test the same length as the quiz, meaning that, it's the same idea. If it took them 18 minutes before, it should take them 18 minutes again. Corey finished his exam in 30 minutes, but was concerned that Sean would not finish in the 50-minute period. How long will it take Sean to finish his exam? Will he finish in time? So how long? We do not know how long it'll take Sean. That is our X. That is our unknown. If it takes Corey individually 30 minutes to complete a test, then his rate is 1 test per 30 minutes, or another way of saying that is after 1 minute he will have finished 1/30th of the test. At least we're assuming constant rate. Sean, on the other hand, we don't know how long it'll take, but we do know that after 1 minute he will have finished that amount of the test, or he finishes 1 test in X minutes. So these rates now are how we're going to be setting this up. We're going to go ahead and say that when I combine Corey's rate of 1/30th of a test per minute and Sean's rate of 1/x of a test per minute, then they will have finished 1/18th of a test per minute together as you add them up. And we've now set up a problem where we can then solve the rest of the way, finding a common multiple, least common multiple of 30 and 18. You can do 30 times 3 and 18 times 5, you'll get 90. So if I do 30 times 3, oh, by the way, the x, 3x over 3x, x is 90 over 90, 1 over x, and 18, I get 5x over 5x. I will get a common denominator of 90x. So I get 3x plus 90 all over 90x, if you want to write it that way, equals 5x all over 90x. Once you have the same denominator, they can be ignored or multiply both sides by 90x if you want to put it that way, so you don't confuse yourself with they can just go away at any time. There's the math in that. We'll get 3x plus 90 equals 5x. 2x equals 90. Divided by 2, x equals 45. So, solving for x does not answer the question. You have to make sure that, it might be the number that you're looking for, but you still have to say it or write it. How long will it take Sean to finish his exam? 45. 45 what? You still have to at least say units and say it. Whoa. I don't know what just happened. Hang on. I went away. There we go. And say it will take Sean 45 minutes to complete his exam. The question is, will he finish in time? They said it was a 50-minute period, so Sean will finish in time. Awesome. That's answering the question. Remember, it's not just solving for x, it's figuring out. They might even ask for his rate. They say, what's his rate? You'll say 1 over 45 minutes or tests per minute. Final problem. Number 6, a local automobile mechanic. Oh, let me talk about the word problem, type number 2. We're going to be looking at something here where it talks about they do different work at a different rate. They can complete so many things. But this in the same amount of time is going to be super important. We can say that the time that it takes this one guy to do his thing is going to be the same amount of time it takes the other guy to do this thing. If you think about it like a hot dog eating contest, and they go 12 minutes long. When Joey Chestnut's taking on Takeru Kobayashi, and Joey Chestnut can eat about 70 hot dogs in 12 minutes, 70 hot dogs, then he has a certain rate that he's going. And Kobayashi's going maybe 62, whatever, hot dogs in that same amount of time. They're going their rate and time, but it takes them that amount of time, the same amount of time to do their own work. So I'm going to be looking at this own set of distance, rate, and time. My distance is actually going to be in terms of car engines. I'm going to go and read the problem after. Rate and time. Remember, distance still equals rate times time. Distance in this case is going to be cars. How many cars you complete. Here we go. A local automobile mechanic and proud father recently hired his son and trained him to operate on car engines. On any given workday, let's assume they work at the same amount of time here, the father can complete work on 12 car engines in the same amount of time that it takes the son to complete work on 2 car engines. So the son's still in training a little bit. He's still a novice. That's all right. So father's son can do certain things. The father can complete 12 car engines in his own given time. The son can complete 2 engines in the same amount of time. Okay, these are the distances for which they can travel or cover. Here's another set and talk about rate. the father's completion rate is 1 car engine per hour faster than his son. Meaning if the son completes 2 car engines per hour, then the father completes 3 car engines per hour. Obviously the son can't do that. Well, actually we don't know. But if the son can complete some amount, the father can complete 1 more car engine per hour. So that means that the son completes X car engines per hour. The father can complete X plus 1 car engines per hour. Now time, I'm going to go and bring this down here. Time is distance over rate. In this case, your distance for father, if I mark him in blue, his distance, his time is 12 cars at a rate here of X plus 1 cars per hour. That'll give you how long it takes him to do that. The son, I mark him in magenta. Oh, no, we're already using that. If I mark him in red, the son's time is 2 cars at a rate of X cars per hour, which gives you how long he does it for. Remember those things that we talked about? I showed you that clip of that guy explaining to his girlfriend that it takes that if you travel 60 miles at a rate of 60 miles per hour, 60 miles at a rate of 60 miles per hour, it'll take you 1 hour because you're dividing the distance by the rate. Okay, anyway, the idea here is that we're looking for this, so first let me fill this out. This is 12 over x plus 1. This is 2 over x. How long is the workday for the father and son? So we're going to figure out what the actual time is. If we figure out this x rate for the son, we can figure out the rest. But the important thing here is they complete this work in the same amount of time. So the idea is the time that it takes father to do this at this rate and the son to do this at this rate is equal. So we get to set 12 over x plus 1 equal to 2 over x. And from here, very simply, you may cross multiply. So I have 12x equals 2 times the quantity x plus 1. That's 2x plus 2. Subtract, I get 10x equals 2. And I get x equals 0.2 or 1/5. Another way of saying this, for the son's rate, the son finishes 0.2 cars per hour, or 1/5 of a car in 1 hour, or it takes the son it takes the son 5 hours to complete work on 1 car. There are a lot of different ways you can say what you're saying as long as you use the same units, hours and cars, in terms of car engine, stuff like that. So the father can complete 1.2 cars per hour, or 6/5 of a car, which is 1 car and then 1/5 of another car, or he can complete 6 cars in 5 hours. But the question is not that. The question is how long is the workday for the father and son. So again, that's saying let's substitute 0.2 for x in either equation and you'll get the same amount of time. So if I do 12 over 0.2 plus 1, that's 12 over 1.2, that is 10. Or if I do 2 over 0.2, that is also 10. So the answer to the question being asked is the workday for the father and son is 10 hours. The workday is 10 hours long. Woohoo! That's a nice workday for father and son, and they get to complete some work on cars. Looks like total they get to, what is it? I guess they work to do 14 cars. Takes them 14 cars work. So that's nice. They get some good business. All right, so that's it. And good. I ran good on time there. You have a test. I should write when the test is. If you are even numbered period, your test is Wednesday. Can't spell it. Wednesday, March. What is that? I'm gonna have to stretch this out. What day is that? What day is today? Monday the 2nd. March 4th. Odd period. So if you have me, your 6th and 7th period, your Thursday, March 5th. All right, that's your exam. Well, that was your practice test. Your exam is on that time. Best of luck to you. If you have any questions, please ask questions on the YouTube comments, School Loop, email, call, text, whatever it is. And hopefully this was a good practice for you. Enjoy. Peace.